In statistical process control, continuous data or measurements can be monitored using a variety of control charts, including the I-MR chart, the X-bar and R chart, and the X-bar and S chart. It is important to consider the size of the subgroup being monitored when deciding which type of control chart to use. When dealing with processes that have subgroups of size 1, the I-MR chart is the best tool to use. In other words, each sample is just one measurement. Individual measurements are plotted along one axis of the I-MR chart, while the moving range is plotted along the other. For a rough measure of the total range of variation in the process, use the moving range. X-bar and R chart plots are suitable for subgroup sizes between 2 and 9. This means that typically between 2 and 9 measurements make up a single sample. The X-bar and R chart plot the mean of each subgroup along one axis, and its range along the other. The range is used to estimate the variability of the process. The X-bar and S charts are suitable for subgroups with 10 or more members. This means that each sample contains multiple readings, typically 10 or more. The X-bar and S chart plot the mean of each subgroup along one axis and its standard deviation along the other. The variability of a process can be estimated using the standard deviation. In conclusion, the choice of control chart depends on the subgroup size of the monitored process, with the I-MR chart being used for subgroup size 1, the X-bar and R chart for subgroup sizes 2 to 9, and the X-bar and S chart for subgroup sizes 10 or more. Here's how a control chart might be useful in a Six Sigma project aimed at making product management more efficient. In a Six Sigma process improvement project, control charts are used to monitor and control process performance by detecting special causes of variation in the data. Control charts help identify trends, patterns, and shifts in the data that may indicate the presence of a problem or a change in the process by monitoring the performance of the process over time. This data can then be used to make data-driven decisions regarding process improvement initiatives. In the context of a product management organization, control charts can aid in the development of robust products by ensuring the consistency and quality of the product's manufacturing process. For instance, control charts can be used to monitor the production process for a specific product and identify any variations or fluctuations that may impact the product's quality. To further reduce variability and enhance product quality, this data can be used to pinpoint the source of the issue and implement process improvement initiatives. In addition, control charts can be used to monitor customer satisfaction and feedback, which can be used to identify areas for improvement and modify the product to better meet customer needs. Therefore, control charts are essential to the success of a Six Sigma project because they provide the data-driven insights necessary to refine processes and create high-quality goods that satisfy customers' demands. A group specializing in product management creates a variety of garden and landscaping tools. They have received feedback from buyers who have experienced problems with the chainsaw's motor. A Six Sigma process improvement project is being implemented to fix this problem. As part of the project, a control chart is used to monitor the chainsaw motor production process. The torque output from each motor is plotted over time in the control chart. By examining the chart, they discover that the torque output varies widely, suggesting that the process is unstable and that there may be an issue with the manufacturing procedure. They improve the process by making sure the bolts are always tightened to the same torque, and they keep an eye on things with a control chart. Using the control chart, we can see that the process is now under control because the torque output is much more consistent and stable after we implemented the improvement. The product management group can rest assured that high-quality, reliable chainsaw motors are being manufactured because they have been using control charts to track the production process and keep it under wraps.